So in our last video for section 6.4, we're actually going to look at an AP free response because this is a common free response question on the AP exam. As I said before, the fundamental theorem of calculus problems are very common problems on the AP exam. You will find these on both multiple choice sections and on the free response. It is very likely that one of your 6 free response questions will involve the fundamental theorem of calculus. Now, I've pulled a question from the 2002 exam, but you definitely can find it on more recent exams than that, and probably on most of the exams from 2002 forward. So let's look at what we've been told. We have the graph of the function f is shown above. It's made up of 2 line segments, and g is the integral from 0 to x of f of t dt. We want to find g of -1, g prime of -1, and g double prime of -1. Now, one of the things I like to do when I have these types of problems is go ahead and just get some notation written down. We know that g of x is the integral from 0 to x of f of t dt. Then that means that g prime, which would be the derivative of that, would have to be f of x. That's what we just talked about as the fundamental theorem of calculus. But then g double prime would have to be f prime of x. Now that may help us here in a minute when we start working on answering these questions. So let's look at the A part. A part asks me to find g of -1, g of prime of -1, and g double prime. So g of -1 would be the integral from 0 to -1 of f of t dt. But I can tell that that is the area from 0 to -1, which is that triangle. Well, that's 1/2 base, which was 1, times height, which was 3. But then that's going to give me 1.5. Now, because we did our integral from 0 to -1, and we're going from right to left, my answer would be negative. We had a property before that told us that. Now I'm going to do g prime of -1. Well, g prime of -1 is the same thing as f of 1, because remember that g prime is equal to f of x. So I just look at my graph, and f of 1 would be 0. And then the last thing would be g double prime of -1. But g double prime is f prime of -1. So if I have the graph of f and I want f prime, we'd be looking at the slope. So if I look at the slope here, at 1, if I do my rise and run, this is actually going to go a rise of 6 with a run of -2. So that answer should be -3. So that answers all of A part. Let's move to B part. For what values in the open interval of -2 to 2 is g increasing, and we're to explain our reasoning. So remember that we know we're increasing when our derivative is positive, but we want to look at, since we're talking about g prime. And I'm going to make a sign chart. Well, g prime is the graph of f. Well, my critical points then become where f equals 0, which is -1 and +1. To the left of -1, the derivative, which would be f, is negative because it's below the axis. Between -1 and 1, it's positive. And then from 1 to 2, you're negative again. So your graph is down, then up, then down. And I want to know, when are you increasing? So you'd be increasing on the interval of -1 to 1. And then my justification for that would be that g prime is positive. Or you could also say something about f of x was above the x-axis. Then I want to know, when is g concave down? Well, concavity comes from second derivative, so we'll do a second derivative sign chart. Well, to get the second derivative, I want the derivative or the slope of the first derivative. So since I have the graph, I want to know when the first derivative slope is either 0 or undefined. Well, we're undefined because we've got this corner right here at 3, or at 0, 3. So then I have a possible point of inflection at 0. So to the left of 0, G double prime, which is the slope of F prime, or the slope of F, would be positive because it's increasing. And then it would be negative from 0 to 2 because we're decreasing. And so my slope then is positive, then negative, and I'm looking for concave down, which would be when I'm negative. So this is concave down from 0 to 2, and my justification would be G double prime is negative. Now let's finish this problem by coming up with the sketch of the graph of g of x. So I've brought over the information that we previously had, our sign charts, our original graph, and remember this was the graph of f, and we want to graph g. Now I'm going to take a moment and go ahead and find some ordered pairs because we can determine those from our problem. Remember that g of x, we said, was the integral from 0 to x of f of t. So keeping that in mind, to get g of negative 2, we would integrate from 0 to negative 2, but that's going to be this area, which is going to be 0, because you have as much below the axis as you do above the axis. Then we already found g of negative 1. It was negative 1.5. G of 0 will be 0 because that would be the integral from 0 to 0. G of 1 would be this area from 0 to 1, which should be 1.5. And G of 2 would be the area from 0 to 2. But again, we've got as much above the axis as we do below the axis, so that's 0. So that's going to allow me to plot some points here. Negative 2, 0. Negative 1, negative 1.5. 0, 0. 1, 1.5. And then 2, 0. And now by using my sign charts, I can look and see that I am decreasing and concave up to begin with. And then I change to increasing, but I'm still concave up till I get to 0. Then I switch concavity, but I'm still increasing, so I'm going to increase concave down. And then the last thing would be decrease concave down. So that would be what our graph of G should look like.